Hello, pre-calculus folks. This is Mr. McAllen, and I have a special guest with us today. It's your favorite Algebra 2 teacher. Sorry, Miss Salvatoriello, Miss Lineski. And we're going to go through a review of what we did this week with polynomials. So to start us off, we are going to...
Can I just say good evening?
I'm
All
sorry.
right, good
Oh,
evening,
no.
everybody. All right, you can't get rid of me. I'm going to follow you guys for the rest of your life, just so you know that. Okay.
So,
Well, thank you for having me, first of
oh,
all.
my
All right,
pleasure.
okay.
Yes.
All right, so what are we doing today?
Okay, well, it says here we have our little
Okay,
cut
gotta-
list
gotta get
of
my
what we're going to be
glasses
working on.
Okay.
So, can you tell us how we would find the maximum number of zeros for this function, Ms. Lineski?
Okay, so now, are you asking them for the all the rational zeros, or just all real
all zeros,
all zeros?
all possible roots.
Okay, so we're talking about the P over Q. Is that what you're talking
No,
about
that would
here?
be when we get down
Oh,
to
okay. I'm,
that.
so, I'm sorry. I'm misreading.
Oh, it's all good.
Okay. All right. So we're okay. So we're looking for the degree.
The degree.
Oh, that's what you're
Yeah,
asking.
the
Oh, okay.
degree. There we go.
All right.
So,
All right.
so what does the degree tell us?
Okay.
The
All right.
degree?
So can I point to that?
Yeah.
Or can they
Oh,
see
I
that?
don't know if they can see
Okay.
that.
You can't see. Okay.
But you can.
All
Well,
right.
I don't know if they can
It's
see
okay.
that.
It's all right. It's all right.
Okay.
Okay.
We're like getting used to working
I'm sorry.
together.
I'm sorry.
Okay.
Okay. Now I'm in the group. Okay. All right. So the maximum possible number of zeros. If you look at the degree of the polynomial, and what's important is the degree has to be in the correct order.
Descending order.
I'm sorry, the polynomial has to be in the correct
Right.
order, descending order.
Mhm.
So this is telling us the degree is 4, so there should be 4 possible numbers for zeros.
Right. Excellent. Okay, so how
Thank
many
you.
possible?
Thank you very much.
That's great. Yeah, good. So I'll take the next one. Possible number extrema, maxes and mins, or terms that the function could have would be 3, because there's always one less than the degree. So then, would you like to tell us about
I would love to. The
Okay.
y-intercept is just where does this graph cross the y-axis? Okay, so what do? We set the x equal to 0.
Okay, so that would be gone, and that would be gone, and that, and we'd be left with 8.
So our y-intercept is 8.
Y equals 8. Okay. Whoa, oh, that's the wrong way
Whoa,
to do intercept.
whoa,
Oh,
whoa,
man.
whoa, whoa,
I intercept. I have coordinates.
Don't do it.
Oh,
Don't do
okay,
it.
okay.
Don't do it.
Hold
All
on.
right,
So
all
I
right,
got to
I'm
say
sorry.
0,
I'm sorry.
8. I'm sorry, Miss Lasky.
Whoa. Because that could be y equals 8. That could be the line. Y equals 8. We don't want to do that.
Well, okay, so this is something new that I kind of discovered with Desmos, and I
Okay.
showed the kids this, is that if let's say they know the end behavior, and they
Did you
know,
say Desmos?
yeah, Desmos.
You love Desmos.
I
don't
love
you?
Desmos. Desmos is my best.
He loves Desmos.
Loves
Okay,
Desmos.
loves it.
I
Okay.
can do that, but okay. But with Desmos, like I was playing around with it, and this term actually tells you as x approaches 0. Like if you do the, it's 4th degree, so it's going to have a behavior that looks like this.
Mhm.
But so we know we have a y-intercept at 8,
Mhm.
and we know that because we have that term, we know that the function will be rising right there. You'll see the appearance of it rising because of that positive slope of 6.
Okay.
So that's one of the things that if you're trying to distinguish one graph from another, that could help. And then we know our end behavior. It has the appearance of it's coming in from the top on the left and it's heading out to the right.
Which they know we did that last year.
Of course,
Okay.
end behavior.
Okay.
They were
Okay.
very good
Okay.
at it when we went
Okay.
over it.
That's very good.
Very well.
I bet you Dan wasn't though. Was Dan good?
Dan?
No,
Yeah.
I
We
don't
shouldn't name
know.
students on the
I'm
video.
sorry. I'm
This is
sorry.
coming
I'm
up.
sorry.
No last names.
Okay.
Okay. I may have to
Sorry.
get you signed a
Okay.
release
I may
form,
have
too,
to.
with
Okay.
the video.
Can we wipe that? Can we get rid of that? Okay.
No, that's
no
okay.
names,
We didn't
no
say
names,
who.
No names. We
We didn't say who.
All right.
Okay, so then we talked already about you guys should know what the end behavior icon would be, but the end behavior icon would look like this, showing what it's doing at the ends. But then we also introduced in this part of the unit limit notation, that as a limit as x goes to infinity, that would be on the right end. As x goes to infinity, the function approaches infinity. So that was the right end behavior. My handwriting is terrible. I'm not even going to write it. You heard me.
Okay,
So
you got that.
right
You
hand
got that.
behavior, and the left hand behavior is x goes to negative infinity.
You heard me.
Right, as x goes to negative infinity for this function, it's going up to infinity, so we'll write infinity. Oh,
Okay.
I think I lost my ability to write here.
Uh-oh.
Hold on, guys. I have to.
Everybody hold on.
I'm going to have to pause this, and we're going to come back.